Let's continue our discussions. When we met last, we talked about how the degree of transport influences the shape of these rocks, where we argued that well-rounded rocks must have been transported over a longer distance, while angular rocks would have been transported over a shorter distance. The other important thing that define clastic sedimentary rocks is sorting, the uniformity of grain size. Do you have grain of the same size being compacted together? Or do you have, for example, larger and smaller materials mixed together? So well sorted materials would have a uniform grain size, right? Whereas poorly sorted materials would have a variety of grain size. So sorting is very important as well because it helps us to get an indication uh, about the consistency of environmental energy that was at work. The environmental energy that was at work to transport these materials, uh, were they consistent throughout or not? So it means if you find materials that are well sorted, it means that there was a uniform source of energy. For example, dunes. Dunes would usually have just those fine sand, right? You don't expect to find some anything which has a different uh, particle size. So dunes are formed by a uniform supply of energy. So it's energy coming from waves. However, you get to find uh, places where you have, for example, clastic sedimentary rocks, uh, where particles are poorly sorted. So it means uh, energy supply, energy that was bringing such materials, varied from time to time. At one time, it can only be able to bring in the smaller materials, uh, whereas at another point in time, it is able to bring in much more larger uh, uh, clastic sediments. So that variation in energy supply results in such sediments being mixed up. Unlike when you have a well sorted kind of sedimentary rock materials where there was a consistent supply of materials because of the consistent supply of energy, if you like. So that's very important for you to understand. So now, here, this is a table uh, giving us some examples of what we call now sedimentary rocks. What are the different kinds of sedimentary rocks out there? So now these sedimentary rocks, the names that are given here are defined based on the size of the fragments that made up such rocks. So now it means uh, if a rock is made up of coarse to very coarse fragments, uh, like just an example, you have a rock made up of rounded pebbles and combos. That is what we call a conglomerate, right? There's a rock called a conglomerate, whereby you have rounded pebbles, much more larger, that have been cemented together, right? But then you can also find a, a fragments coarse to very coarse, but larger, largely angular in shape. So those are what we call breccia. So now you would realize, for example, if you have something medium to coarse fragments, that would give, for example, what we call a sandstone. For it to be called a sandstone, it's basically because it's made up of medium-sized grains, which are sand, right? But then you also get to find those that are made out of quartz, uh, uh, sand-sized rhythic crust, and so forth. So all those gives all different kind of names. Then you get to find those that are much more finer. A stone made up of fine particles. That is what we call, for example, a sealed stone, right? Later on in your career, you would go to a place called Humeb Silt. Humeb Silt is found in the Namib Dankruf Park, located along the Kwiseb River, at a place called Humeb. Maybe later on you would go for an excursion to Gobabeb, or you would work at Gobabeb. Then you'll be taken to Humeb Silt. So you have a silt stone made up of fine, uh, fine grains, right? Very, very fine particles, but such particles are cemented together. The same is true with, for example, getting what is called a clay stone, right? A clay stone. A clay stone, because it's made up of clay, and the clay we know, it's those small, small, small particles, right? Clay is much more smaller than sand. And that is what brings us, for example, shale, mudstone, or clay stone. So it's a rock, but it's made up of fine sediments that are cemented together to form that rock. So now, from a hydrological perspective, you will understand that aquifer is water, right? Water, groundwater. Aquifers are largely found within sandstones, right? Because sandstones are permeable, they have pore spaces that allow water to infiltrate. Yes, sandstone allow water to infiltrate, unlike siltstone or mudstone or shale or clay stone, which is largely made up of such small particles that are stuck together and does not allow water to infiltrate in there. So it's very important to understand, therefore, that uh, sandstones are basically stones made out of sediments. So again, you would realize that the name of each sandstone, could it be a conglomerate, could it be a breccia, could it be a sandstone, could it be a siltstone? That name is basically based on the materials used, or materials that were rather that were eventually stuck together through the process of recification. So what was the size of the crusts that were brought together in order to form that rock? So that's very important for you to understand. Okay, so let's end here. We would continue again later.